Dr. Romm, welcome to Clean Titans. You've had an extensive career focused on climate science and policy. Could you share what initially drew you to this field and what key experiences shaped your perspective and a little bit from your storied career, whatever you'd like to highlight?
Sure. Well, thank you. I have been doing this a while. I first got interested in physics because my uncle was a great physicist, and he was really good explaining things. And really, as small to me, he explained why the sky is blue and why ping ponging inside a raindrop becomes a great rainbow. And so I decided I'd like to be able to explain things too. And so I pursued a PhD in physics from MIT myself and ended up doing, spending on Capitol Hill and spent a couple of years at the Rockefeller Foundation and was able to talk to a great many people when I was at the foundation. And I would always ask them, what's the next big thing? This is around 1990. And they would always, not always, but many tell me, it's clean energy. So I wanted to get more training there, and I ended up working for Amory Lovins, who ran the what was then called the Rocky Mountain Institute in Old Snowmass, Colorado. Now it's called RMI. Now it's a very big place with many. Back then there was about 40 people, and worked in a building that we leased from John Denver. Then in 1993 and 1992, Bill Al Gore elected president, and Amory recommended me and other people for the administration. And I did end up working at the Department of Energy as the special assistant for policy and planning to the deputy secretary. He was in charge of all the energy programs, so I got a little taste of fossil energy and nuclear energy, and he really wanted me to focus on clean energy, renewables, and efficiency. And ultimately, I did end up running the $1 billion Office of Energy Efficiency and Renewable Energy. And that was a great learning experience. We did solar and wind and alternative fuel vehicles and batteries and advanced lighting and industrial. I went from there to doing a lot of consulting in this area until August 29, 2005, which is when Hurricane Katrina made landfall. And my brother happened to live in Pass Christian, Mississippi, which was the site of the worst storm surge to ever hit the United States at 20 feet. So his house was obviously dead, like the inside of a washing machine. He said a few weeks later, he asked me this question, which really did change my life. He asked if he should home, and he was basically asking, are we going to keep being things like these? And so I started talking to climate scientists and reading literature and going to seminars. And I concluded two things. One is, yeah, the situation was more dire than I thought. And second, that scientists were doing a great job of communicating. So I decided to become a full time communicator. And I ended up Center for American Progress, writing a blog, founding a blog called Climate Progress, which people probably know me through. And I did that for 13 years, and it became very widely read. And it was a good my skill set because my father was an editor for 30 years, so I was used to meeting a deadline. And I met a great many people over the years as a result. People like Al Gore, people like James Cameron. Ended up working on a TV series with him, Years of Living Dangerously, that I think people saw as really one of the best things I think ever done on that. And I met climatologist Michael Mann. And ultimately, when he founded the Center for Science, Sustainability, and the Media at the University of Pennsylvania a few years ago with Kathleen Hall Jameson of the Annenberg School, he and I've ended up working with him for the last 2 years at UPenn and writing a lot of analyses of climate solutions, the kind of more questionable ones. Decided to update this book I did in 2004 called The Hype About Hydrogen, since hydrogen kept getting. It was kind of a skeptical book back then, even though I had, when I was at the Department of Energy, I helped increase the budget for hydrogen and fuel. But now, 20 years later, it's something people want to spend a great deal of money on, but it's really even less of it makes less sense than it did 20 years ago. So I wrote that. It just came out on Earth Day, and it talks a lot about hydrogen and other kind of false promises, like in my mind, small reactors and e-fuels and fusion and direct air capture. Not that these things aren't. We certainly should development in many of these things, but they're not ready to scale, and some of them are going to take a long time to scale. And I think we do know what the solutions are that we should be making major investments in terms of deploying those technologies. And I'm delighted with you about this.
You've been communicating about climate change for many years. What are the most alarming trends you're seeing today, and how do they compare to previous predictions?
Well, I think by and large, scientists tend to be conservative. And so the scientists come to a consensus, which is, the intergovernmental climate change, the big reports that come out in 5 and 6 years. And they do have best scenarios and worst case scenarios in them, as you would expect. But in terms of the way scientists have historically talked about climate change, it's really been cautiously, not trying to case scenario B. And as a result, many of the estimates of what would happen, let's say, if you go back to 2000 and what people were saying in those reports is would happen by now, by and large, I think we are either in the mainstream of those predictions, or in some cases, things are considerably worse. And some of the worst is I don't think it was fully appreciated then because it was hard to model how bad the extreme weather events could be. I mean, not because temperatures rise like a degree, it's because it increases the likelihood of, let's say, a once in a thousand year storm very disproportionately. And that's where you get the superstorm Sandy, right? That's where you get the LA fires. And that's where you get these monster heat waves that people have been seeing. And so I think the reality of just had these extreme weather events would be has surprised people. And partly because the climate isn't linear. And one of the things we've learned is that as the planet warms, the jet stream weakens. And if the jet weakens, that means that weather fronts don't move through as quickly. They can get stuck. So a rain event like Superstorm Harvey over Texas can rain, almost not move 3 days, and it becomes what was calculated to be a once in 25,000 year, rain event. Which is obviously it's not 25,000 anymore, but that's what it been if there had been no human emissions of greenhouse gases. And so I think we see that heat waves. That's also one set of things. Then there's this issue of, are we starting to evidence that we might be warming? Warming might be a very hotly debated topic. I'm sure you probably had experts come on the show and talk about this. I don't think the jury is entirely out, but we're clearly starting to trend towards the upper end of the basic on projections. And whether that is going to tell a very big tale as to whether we are, in fact, truly accelerating, which is what the models always predicted. As sea it's rise, it's going to, the rate of increase. So the question is, how fast is it? And clearly, another trend, well, look, we have been right. The 30th conference of the parties to the UN Framework Convention on Climate Change. And I think if you had gone back, 30 years and have 30 of these and emissions are going to keep rising, I think people would be shocked, right? We're kind of used to it, but it's still shocking, the dawdling that for 30 years, and the ability to see things like, oh, can we say phase out fossil fuels or not? It doesn't matter what those words are. It matters that you start reducing emissions and you do them faster and faster. So I think that has been disappointing. The other big surprise, I think, has been methane emissions. I think we thought they were starting to level off, and then they have just really taken off on a very high, fast track level. And if we don't get a handle on them, it is very concerning in the short term because they have their global warming to 20 years is 80 times larger than that of carbon dioxide. Right. We worry about carbon dioxide because it stays in the atmosphere for centuries. Right. So you really don't want to emit carbon dioxide because once you've done it, it's going to warm the planet for a very long time. But you also don't want to emit something like methane because over the short, we're obviously near certain tipping points that people have worried about, right? Many of us had hoped we could keep warming near 1.5 degrees Celsius, which is to say Now it looks like we're going to have difficulty. We're going to go past 2 degrees Celsius on our current path, and that means if you want to avoid that, and I think we should avoid that at all costs, then we need to focus on reducing things like methane quickly, but also getting a handle on CO2.
We were already there for 1.5, right?
Yeah, we are.
And you mentioned Houston. I was in Houston recently, and I was talking to a hydrologist, and he was just explaining about water flows in the
Yeah.
area. And I just asked him out of the blue, what's going to happen in 100 years? And what he said shocked me. Majority of Houston is going to be part of the Galveston Bay Area.
I think that's right. I think that you look at politics in the state of Texas and in this country, right? We're not started to reduce emissions sharply, and now we just heard today that the House of Representatives would like to scrap basically the entire Inflation Reduction Act, the act that authorizes hundreds of billions of dollars for clean technology, solar, wind, batteries, heat pumps, and electric vehicles. I think that's true. And after my brother lost, talked to a great many experts on sea level rise and hurricanes. And I wrote a book called High Water. So I think it is safe that, yes, that's another, when you ask things I worry about. On the east coast of the United States, we have seen sea level rise much faster than the average rate the planet has seen, 2 or 3 times faster, right? And so I think some cities are going to be very hard to save. Galveston, but assuming we get from our current administration, then yeah, I think we're headed towards a moderate severe case of warming. And I think you would find it very hard to sustain even a city like Houston, and obviously, that's shocking. And I think it's important. We could see 5 sea level rise by the second half of the century. When exactly is hard to predict. Part of it depends on whether we are aggressive to fight or not. But then it keeps rising, right? I mean, it's going to keep rising. And, your major coastal cities are make big decisions. Can you save them or kind of have to triage them? Certain places are just going to be very safe.
Especially the ones that are already below sea level and sinking from all the weight.
Right. And so yes, so that's your New Orleans for sure. Right. Its biggest problems. It's got a lot of people living below sea level. You have places in the Carolinas, the coast of the Norfolk, Virginia area, but Galveston, Houston area, and it's going to be hard to protect as the sea levels. And then on top of that, right, that's the challenge, right? If you want to do a seawall, you can't design the seawall for simply the average level of sea level rise you expect. You have to build it for that plus a super 20-foot sea line, the sea on that, right? So you're talking about, are you really going to build a seawall that's 20 plus feet high? I mean, imagine what that would mean for. So I don't think people have with what this means and what it means trying to insure coastal property. Right, we're already seeing it's increasingly hard to insure coastal property. It's increasingly hard to insure a home that's in a fire zone, right? In a wildfire zone, California, um, and even in a floodplain, even if it's not on the coast, we have many floodplains. There are places, as I'm sure you know, in where it rains and it floods. So there isn't really a safe place. I know Toronto, Canada. Yes, I think that there is a reckoning coming. It's not going to be 100 years from now. The reckoning comes when the financial industry and those who insure and those who write 30-year mortgages realize that this area is unsavable, right? And we are getting to the point where one can say, on our current trajectory shift, this area is likely to be unsavable. And is a bank going to write a 30-year mortgage for an area that has a good chance of being hit by a category 4 or 5 hurricane, or having something like a devastating wildfire, or simply or deluge, or perhaps this extended drought? So I think that the economy is built on to see what's happened in the last 3 months, to see what happens when a little bit of instability comes in. So yes, I think that it's kind of tragic that we live in a world where disinformation about change and disinformation about climate solutions still is as dominant as it is, and some would argue it's become more dominant. You can choose your news source. And if you don't want to hear the reality of climate science, you don't have to.
There was a report about $1.5 billion of property value that's going to disappear.
1 trillion blog on this coastal property value is going to crash. And we're already seeing coastal property in areas that are in flood zones or wildfire zones do not grow in value as fast as other places. And I think as I say, everyone knows that it's getting hard to insure properties, and ultimately that means that a lot of places can only be purchased by people so wealthy that they can simply afford to lose the property, or simply say, it's not the end of the world. People, 95% of people, you can't possibly afford to live the value of your home that you put much money, effort, and memories and love into.
In your recent, you highlighted the Berkeley Earth analysis on the unusual temperature spikes. Could you elaborate on the implications of this spike and whether the past warming rate is no longer a reliable predictor of the future?
Well, the Berkeley Earth people, they're one of the people who do sort of original analysis and I think they put out very solid work. And they raise this issue. There's indications of the last few that high end of the envelope projections. So that's sort of an ominous sign. The past temperature rate of rise since 2000 isn't going to. There are possible reasons for this. Some of which is reducing particulate emissions, sulfur dioxide emissions, shipping and coal, because those actually block the sun. So it was always understood, in some sense, we were being shielded from the totality of the global warming impact because of the dirty soot and such that came out along with the CO2. And naturally, we were always going to want to get rid of those um, particulates because they're well documented to have many harmful effects, direct impact on your cardiovascular system, your cardiopulmonary system. And now we know even pretty strong evidence that particulate exposure is linked to dementia. And a lot of countries have been working to reduce those. At the same time, methane emissions have been higher than expected. And there's also concern that the permafrost, which is kind of like a frozen locker of carbon, there's been studies and measurements in the last 10 years been thawing out. And there's more carbon to the planet than there are in the atmosphere right now. So the frozen tundra and permafrost could maybe starting to emit CO2 and methane. So I think that the literature that said people obsessed over 1.5 degrees Celsius was a number pulled out of a hat. The same for 2 degrees Celsius. Literature, the UN Intergovernmental Panel did a massive report on 1.5 degrees Celsius at the request of the UN. After Paris Accords, nations were going to we're going to limit warming to the really aspirational goal is 1.5, and the parties to that asked the UN, could you tell us, reanalyze the data? What is the latest data saying about the safe level of warming? And they came out with a report on 1.5 degrees C, which they basically said, as you go from 1.5 C to 2 C, you are dramatically increasing the impacts and the risk, right? It's not like there's a cliff, right? There's not a cliff represented, oh, if you don't hit a certain target by 2020, it's all over, right? That's not true. What it is that you are getting bigger and bigger impacts, more and more extreme weather, faster rate of sea level rise, but you're also getting closer to tipping points that can really speed things up, like the melting of the permafrost. And nobody knows exactly right what those points are. They just know that you are getting closer and closer the more you go above 1.5 degrees C. We are taking a dangerous and experiment on the planet, and we should be using the precautionary because if we were fully rational and fully moral, we would be considering getting anywhere near 2 degrees C. Whereas, in fact, we're currently on track to blow past 2 degrees C sometime by mid-century or soon thereafter.
So, what are the most to achieving our goals to stick to 1.5 to 2 degrees?
Well, look, let's start with the reality. I wouldn't be here. I didn't explain that. Yes, we do know. Let's don't want to say that we go to. I don't say we would go to zero tomorrow. That's not what we're talking about. We're not talking about stopping fossil fuel consumption tomorrow. We are talking about reversing the growth in emissions at least as quickly as they went up, right? And we have them. I mean, the staggering uh, improvements, cost and solar power, batteries, electric cars, electric heat pumps, and other technologies has, as I think, surprised even many of us who were involved in this for a long time, enough to dramatically reduce global greenhouse gas emissions over the next quarter century. Could we get to zero in 2050? Well, we could. I'm not going to say it's easy, but I'm also not. It's hard, it's straightforward, but it is politically, in the best of worlds, it's politically challenging. It's in a world where, let's say, one political in this country and a large fraction of the people in this country have been so immersed in disinformation that they simply don't accept basics of scientific reality. And so biggest obstacle right now is the politics, the fact that time you shift, change the world large scale, and we are talking a large scale. I think that's the main point I try to know in the book about hydrogen is that we emissions are 50 billion greenhouse gases, right? Oil consumption is 100 million barrels of oil a day. I mean, I don't. It's beyond imagination, right? It's just this is not. So replacing all that is a while, and it's going to require some changes. Now, in the case of electric vehicles, it was clear to me for a while, and I think it is increasingly clear that electric vehicles are simply a superior product. They are coming. That's why more than 50% of vehicles being sold in now are electric. China has decided that they want to be the leader, and they a suite of technologies in both vehicles and batteries are game changers. I think a key point is that the electrification of the world large is going to be quite beneficial because we're going to get rid of a lot of air pollution, which currently kills 8 to 9 million people a year, right? And we are going to slow and then stop climate change. And of course, CO2 goes into the ocean and acidifies it. So, for all the benefits, but it is certainly true that the incumbent industries, the fossil fuel industry, right, makes $1 trillion a year. So they have a lot of money to spend pushing the status quo and debunk and trying to spread misinformation on the nature of the problem. So, that's the biggest challenge, I think. It's clear that most people would like to take stronger on climate change. There's a lot of misinformation about that. And most people are surprised to realize that most people believe that, right? The people who spread disinformation are so noisy that even though they're hardcore skeptics are under 10% of this country. Nearly half the people are alarmed or concerned around talking about it in parties and stuff like that. So most people don't hear about everyone else's concerns, but often hear disinformation. So I think that continues to be the biggest problem.
Your book, the challenges the belief in hydrogen as a key solution. What are the core arguments against relying heavily on hydrogen, and what are the most significant misconceptions you aim to dispel with your book?
Well, I think the most important thing to realize is that hydrogen, it is currently used in the economy. It's made primarily from fossil fuels, from hydrocarbons. You extract the hydrogen, you let the carbon loose in the atmosphere as CO2. So the principal way is you take methane, which is the principal component of natural gas, and it is one carbon and four hydrogen. Four. So there's a lot of hydrogen in there, and so we currently, you reform natural gas and you take the hydrogen out and you emit the CO2. Currently, the world uses about 100 million tons of green hydrogen a year. The single biggest is to make ammonia fertilizer. right? Ammonia is one nitrogen and three hydrogen atoms, NH3. So we use it for ammonia fertilizers. The petroleum industry uses it to hydrogenate petroleum, which is makes it cleaner, um, and it's all used for manufacture other chemicals like that. Responsible for 2% of global greenhouse gas. People have been trying 30 see if they could make hydrogen into an carrier that could be used in the energy economy to replace dirty energy and thereby be a climate solution. They have been trying and failing. Literally today, 0.1% of all hydrogen made is used for such purposes. All the rest is used as a chemical feedstock. Um, to give you an idea of the scale of the solution that's needed, if you wanted to make from renewable power rather than fossil fuels, the way you would do it is you would use the renewable electricity, you'd purchase an electrolyzer. The electrolyzer takes the renewable electricity and it splits water with electrolysis into, and water is H2O, and you generate clean green hydrogen that way. It is a very inefficient process because, after all, we burned hydrocarbons in the first place to extract energy from the hydrogen and the carbon. We burnt or oxidized the carbon into CO2, and we burnt or oxidized the hydrogen into water, right? So water is the end state, it's the waste product of combustion. So if you want to try to split that hydrogen back out again so you can use it, clearly you're going to have to put a chunk of energy in, and you're going to have to buy a device which is called an electrolyzer, which is not cheap. People thought it would get cheap. They thought it would come down a learning curve the way solar and battery did, but it didn't. And there's been a lot of confusion. I think the single biggest myth or magical thinking that you see in this space is that everybody has their business plan that says, oh, our technology, as it gets used more, is going to come down a learning curve just the way solar and batteries did, right? But as it turns out, most things don't, because an electrolyzer is still a lot of cement and a lot of hardware that just isn't going to come down a learning curve. And much as someone famously said, they're still waiting for their iPhone to come down and cost to $50, right? Some things simply don't, most things don't go down as solar did 99% in 25 years, right? That's because of our expertise in semiconductor manufacturing and that spread to silicon manufacturing of solar panels and all that sort of things. But the point is that no, not only did electrolyzers not steadily come down in price this decade, they actually went up in price 40 to 50% in the last 3 years. And because of that, all of the projections of green hydrogen costs suddenly being affordable, they all blew up. And because of that, only 1% of all hydrogen projects out there have firm offtake agreements, have someone who is a guaranteed buyer to make that project work, right? So essentially, the green hydrogen market blew up in the last 6 to 12 months. And so that's sort of problem one. And that is to say, the myth of cheap green hydrogen has basically blown up. There are other big issues with hydrogen in general. One of which is that we didn't really know 20 years ago is that it actually warms up the planet much more than we thought. Hydrogen is not a direct greenhouse gas like CO2 or methane. It doesn't directly trap heat. But if you release it in the atmosphere, it extends the lifetime of methane and extends therefore the abundance of methane in the atmosphere. It also extends the lifetime of some other greenhouse gases in the atmosphere, and therefore it has a global warming potential over 20 years of 35, which is 35 times that of CO2. But hydrogen, being the smallest molecule, the smallest element, is the leakiest gas there is. And therefore, if you imagine scaling up usage of hydrogen, you're going to be scaling up emissions of hydrogen. There's no real way of getting around that. And so you're throwing another short lived climate forcing mechanism into the atmosphere. And not only that, you're doing it at a time when methane emissions are also going up. And the two of them together are a very dangerous combination. And there are many other issues with hydrogen. It's because it's so light and small, it will leak through almost anything. So you can't put it in a natural gas pipeline, right? It'll actually destroy that pipeline. It will embrittle it, and you can Google that. You'd have to design a very special coated interior of the pipeline and all the components that are exposed to the hydrogen, and it would be quite expensive. That's why a great deal of hydrogen is shipped around in either compressed tanks, kind of like the tanks of gas that you see in hospitals, the big cylindrical canisters. But again, it's such a diffuse gas that like 95% of the weight is the canister. So you're going to have these diesel trucks, as we currently do, shipping around huge canisters with a little hydrogen in them, right? The greater the distance, the more the energy balance gets worse, which is why a lot of hydrogen is shipped in a liquefied form. And you hear a lot about liquefied hydrogen for trucking or for shipping or even airplanes. And it's really kind of ridiculous because liquid hydrogen has to be cooled to near absolute zero, below negative 400 degrees Fahrenheit. This requires about 40% of the energy in the hydrogen is the equivalent of how much energy you need to cool it that low. And if you have to ship it, then it's going to slosh around and start to warm up, evaporate, build up pressure. That's called boil off. And you typically vent it directly into the atmosphere. And if you don't want to vent it, you'd have to spend a lot of money to keep it cool, right? You wouldn't just have to have a big thermos, you'd have to have a big cooling system, recapture, and none of our current vehicles do that. And so one of the things about hydrogen is just it's a very impractical thing to use, which is why no one uses it as an energy carrier. And one of the other big problems with hydrogen is that its biggest competitor was always going to be electricity. If I want to drive a car with an electric motor, which is what an electric vehicle is, then I can take renewable electricity and run it through a wire, the power line, charge up a battery on a car, discharge the battery into the electric motor, and run this electric car. And that's how we do it. And that you lose about 20% of the electricity along the way. The hydrogen idea is that you take the renewable electricity, you buy the electrolyzer, you electrolyze the water with the renewables, you lose about 30% of the electricity. You then take the hydrogen, you compress it or liquefy it, you figure out how to ship it, squeeze it onto a car, you put a fuel cell on the car. The fuel cell is like a continuously fuelable battery, but it runs on hydrogen. It turns the hydrogen back into electricity, throws away at least half the energy in the hydrogen doing that. So you just end up with the original electricity, but you've thrown away 80% of it and you've paid for an expensive electrolyzer and fuel cell, and you're running the same electric motor. All those hydrogen fuel cell cars out there, and there's not many because they never proved economically viable. There's literally 1,000 times as many electric vehicles on the road as there were hydrogen cars, which is what I predicted 20 years ago. I wrote a book in the original hydrogen. In the paperback, I basically explained that hydrogen is just never going to. If you could do something with electricity directly, with renewable electricity directly, you would never go through this laborious process, which in the book I describe as if I want to send you water, I turn it into champagne, I ship you champagne, and then you distill the champagne and get the water back out, right? That's what we're talking about here. It really doesn't make a lot of sense. And the fact that we continue to pursue it, despite the fact that its inherent inefficiency is a matter of the laws of physics, it's not something you can say, oh, we will solve this with 20 years of R&D. No, you're not going. You might improve all of these things and come up with clever fixes and kludges that make things a little better, but you can't get around the fact that you are going to be wasting a lot of the renewable electricity, and it's going to cost you a lot of money, and you've got this fuel that doesn't actually have that many uses. And for instance, heating, right? We didn't know maybe 10 years ago, 15 years ago, how good you could heat things with an electric heat pump. But they have gotten very much better, much more cost effective. And in most places, they are now actually cheaper. They can also be used for air conditioning. You don't have to buy a boiler and an air conditioning system in a new unit. So for new facilities, it's hard to justify why you would want to buy an air conditioning system and a gas boiler when this system is super efficient, is sort of magically efficient. Maybe it's worth explaining briefly. The heat pump is not using the electricity to heat up a wire. Like your old incandescent bulbs, they got hot, right? Because you ran electricity through a filament. The filament heated up, and that shone a bright light, but it also wasted a lot of energy and heat, right? That's why LED bulbs have replaced incandescent bulbs. A lot of people had used heaters, and we have them in our homes that are so-called resistance heaters, right? They simply run electricity through a wire, the wire heats up, and that gives you the heat. But again, very inefficient. What the electric heat pump does is it takes the refrigeration cycle and runs it backwards, and it allows you, instead of removing heat from your home, it removes heat from the outside and brings it into your home. So it means 1 kilowatt hour of electricity in could heat up your home with 3 or 4 kilowatt hours of electricity equivalent, right? So that's why they're starting to win in the marketplace, and I think you're going to be seeing them more and more. So the point is, we do understand that the future is electrifying the U.S. and world economy, and that's what we need to be spending our money on, both particularly the deployment money, which is the expensive money, right? That's the vast majority of money goes into deployment. We should do R&D, research and development, on a lot of different things, even speculative things that don't have a lot of chance. But we shouldn't be distracted by those other things like hydrogen into thinking that they could ever be a major climate solution that could compete directly with electricity. It's so wildly implausible that no one should base any policy on it. That was my major conclusion 2 decades ago, and it's even stronger conclusion today. And I think most people in the field do understand that.
In your recent post, you discussed the major companies scaling back investments in hydrogen. Could you
Yeah,
explain the economics and the practical challenges? You already
yeah.
mentioned a bunch of them.
Well, in the last 6 months, this magical thinking about, oh, and I will say, look, I worked at the Department of Energy for 5 years, and I'm a big fan of the work they do, but they tend to be boosters of everything. And 5, 6, 7 years ago, they had a goal that they were going to take green hydrogen, which they said was $5 a kilogram, even though it really wasn't. That was what it would have been if it were at scale. And they said, we'll get it down to $1 by 2030. Right. And a lot of people did similar analyses, basically pulled numbers out of a hat, really. And so a lot of people made investment decisions on the basis of, oh, we're going to start investing in hardware and other things, and convincing people to spend a lot of money scaling things up on this belief that green hydrogen was going to get cheaper and cheaper and cheaper. So that blew up. That magical thinking has largely blown up in the last 6 to 12 months. I'm not saying that serious people believed it was likely before then. I'm just saying it's one thing for us to predict that's going to be the case. It's another to see in the marketplace electrolyzers jump in price rather than keep coming down in price. So even companies that are very strong believers in hydrogen, and the article I wrote about was about Ballard Power, which has been around a long time. It's a fuel cell company. It principally made low temperature fuel cells, these PEM, proton exchange membrane fuel cells. You needed a low temperature fuel cell to run a car. We have high temperature fuel cells, but they take too long to heat up, right? You want a car that starts fast, so you need a low temperature fuel cell. Um, so Ballard, in the last, just last week or two, came out with a statement that they were pushing off their estimates of when green hydrogen would be affordable till, let's say, the end of the decade. And therefore, they were going to be scaling back their investments. The other company that scaled back their hydrogen was Air Products. And Air Products had major investments in the development of they're an industrial gas company, and they have major investments in a number of hydrogen projects, some green and some blue hydrogen in particular, one in Louisiana. And their shareholders were getting increasingly concerned about the viability of these projects. They voted in 3 new board members. They replaced the CEO. And in the last several weeks, Air Products has been scaling back its investments in this so-called hydrogen economy.
Can you explain the difference between green, blue, and the other types of hydrogen and natural hydrogen?
Sure. And let me just, sort of say as a caveat that in the book, as you know, I'm not a big fan of all these colors. There's literally over a dozen colors that are used, and I think it's all a lot of hype and marketing and branding to try to persuade people that that anything but green, anything that there's more good ways of making hydrogen than simply using renewables. And so your dirty hydrogen is sometimes called gray hydrogen, made from natural gas, and the green hydrogen is made from renewables. They have invented this term called blue hydrogen, where the hydrogen is made from natural gas, but we're going to capture a lot of the CO2 from the process. The thing is that there are no commercial blue hydrogen projects, and they would be incredibly expensive. They'd have to be large. You can't easily build a small one. And what's more, they're not going to be low carbon because they're made from natural gas, and natural gas has a very has leaks in the hydrogen production and delivery infrastructure, right? And those leaks are of methane, and methane, as we discussed, is has a very high 80 times the global warming potential of CO2. So even the leaks of maybe 3 or 4% are enough to make so-called blue hydrogen relatively dirty if you could capture all the CO2. But again, no one has successfully commercialized large scale carbon capture and storage, right? Some people keep trying to do it. We've been trying to do it for 20 years, but not very successfully. And nobody has ever been able to capture consistently. I should say, on average, the amount of CO2 captured is typically like 70%, and some it's considerably lower. And there's no reason to think that capturing CO2 from a methane production of hydrogen is going to be any better. So if you actually look at what would likely happen in the real world, this is not going to be terribly green. This is not going to be low carbon. It is, however, something that the fossil fuel companies want to do, right? Because they want to keep having a justification for drilling for and extracting and transporting natural gas.
Something they know how to do.
It is something they know to do, and they know how to transport hydrogen, right? Most of the fertilizer plants in this country are located near petrochemical refineries and facilities because, again, no one wants to transport hydrogen far, right? So if you're going to have, a place that has oil and gas and makes hydrogen for the petrochemical facilities, you're going to also want to build your fertilizer plant near that, and that's where most of them are. So yeah, the petrochemical industry is certainly very familiar with hydrogen production, hydrogen transport, and hydrogen safety.
They're in a commodity business, molecule business, so they know how to move molecules, trade molecules, and move molecules. So
Right. And yeah, and the people who need hydrogen as a molecule, they don't have alternatives, right? If you want to make ammonia, right, you're going to need hydrogen, right? You're going to pull nitrogen out of the air, right? The point is the ammonia fertilizer are going to fix nitrogen for agriculture, right? The big great advance of the last century. So you pull nitrogen out of the air, and then you have a process that combines it with hydrogen. So I don't want to say it doesn't matter what the cost of the hydrogen is, but and no one cares until global warming came along that hydrogen was made by emitting CO2, right? Because we're trying to feed people, and that's obviously a great priority. So the point is that, yes, the fossil fuel companies have been pushing the hydrogen economy because they never thought green hydrogen would work. And they always thought that people would have to come to them to make the hydrogen with natural gas. And would you pretty please capture some of that carbon and bury it or do something with it? And it just, people got carried away with this dream of a hydrogen economy compared to the reality that it's a pain in the ass, it's expensive, it's inefficient, and it's in the real world, it's not going to be that green.
What energy sources or technologies do you see as more promising and scalable alternatives to hydrogen for decarbonizing various sectors, such as hard to do transportation and industry?
Well, I think that we have the supply technologies and then we have the products that run on electricity, right? I think clearly the goal is to run as much as you can on electricity. And that means because solar and wind are variable, you need to develop either, ideally, you develop a carbon free form of electricity generation that isn't so variable, right? That maybe even has some storage in it that can be used not so much as base load 24/7, but as dispatchable power, that you can dispatch it when the wind isn't blowing as much or it's not sunny outside. Many people have been pushing nuclear. We have been trying to do nuclear for decades. OECD, it's basically come a dead end because the price of new nuclear plants has gone up and up. The last nuclear plant we built in this country, the only plant we built in the last 2 or 3 decades, is the Vogel plant in Georgia. It's two nuclear reactors. It's about 2,000 megawatts or so, 2 gigawatts, a little bit more, and it cost $35 billion, the most expensive plant ever. And in the book, I have a long discussion of why smaller plants would be more expensive per megawatt. And that's just, happy to talk about that another time. But we do not know how to make nuclear power cheaply. And it's not clear anybody does. The only country that's building any substantial number is China, and they're not really a market economy, and their state owned industries, they can get special interest rates and, all sorts of kind of things that we can't do in this country. And they're not building many nuclear plants, just to be clear. They are building 35 gigawatts of nuclear plants from 2024 to 2030, which is vastly more than anyone else. But last year, they built 350 gigawatts just of solar and wind. Right. So 6 years of 35 gigawatts of nukes versus 1 year of 350 gigawatts of solar and wind. And yes, the nuclear plants do have higher availability. The solar and wind don't have the same capacity factor. But the point is, the future is solar and wind and storage, and they know it. And the trick is just to keep making the storage better and better. And we're putting a lot of money into longer and longer duration energy storage. There is a form of renewable power which is starting to get a lot of attention that would, in fact, be carbon free and dispatchable, and that is enhanced geothermal. Maybe you've had people come on the show and talk about enhanced geothermal. I think it's not a, I won't say it's a slam dunk. I will say that it is more promising than small modular reactors. Jigar Shah, who was the head of the Department of Energy loan program for the past 4 years, which issued $100 billion in loans and probably knows as much about commercialization as anyone. The DOE loan office, together with the rest of the department, put out these liftoff commercialization reports. And Jigar was asked on a podcast recently to give the answer to the question: where does small modular reactors, advanced nuclear, stand on a scale of 1 to 5 on likelihood of commercialization in the next 5 to 10 years, and where does enhanced geothermal? And he said currently for nuclear, he'd put it at a 2, and for enhanced geothermal, he'd put it at a 5. So I think that the only good news coming out of this administration is that they are supportive of enhanced geothermal. And in fact, the current Secretary of Energy had been an investor in a geothermal company. The reason geothermal is becoming plausible is by using the technologies developed during fracking, which is to say, very deep drilling, horizontal drilling, and 3D, all these related technologies and the like. And to do enhanced geothermal, you would definitely want to use people who had experience in the oil industry and gas industry, drilling deeply and doing other things, related to deep drilling. So, and I think that then you talked about this issue of, okay, let's say we have a supply of reliable carbon free power. We have a grid that could be 100% carbon free because it's got some leftover nuclear plants, it's got leftover hydro plants, and it's got solar, wind, and maybe it's got geothermal, right? And we construct a grid that way. And maybe it's got some backup fast starting gas plants for the once in a thousand year scenario. These you construct a grid like that. Now, how do you address some of the hard things like the industrial sector, like shipping? And the answer is that in the case of the industrial sector, it looks like we can electrify more and more of it, right? There are a lot of people who are working on using, industry uses a lot of high temperature heat, right? Now we're developing industrial heat pumps that can take you up pretty high. I think they can go up to 180 degrees Celsius is currently what people are talking about. People are working on higher numbers. Then maybe you've interviewed some of the companies that are working on higher temperature heat with electricity, very sophisticated sort of technologies, which again, I won't go into, but potentially very high temperatures. Then you have a complicated area like steel, right? Steel needs to reduce iron ore, needs to pull the oxygen out of iron ore. And currently we use coke and a blast furnace. It is possible to use hydrogen as a reducing agent. You would have to make it from something. People can make it from natural gas. Could you make it from natural gas and capture the CO2? Or could you go to a straight electrolysis? Could you do it strictly with electricity? We don't know exactly yet, but there are people who are doing that. We do in this country. All of the recycled steel is made using an electric arc furnace, right? So a very large fraction of the steel that we use is actually recycled steel made with electricity. But there are people who think they can make primary steel with it. And I would say the same thing I'm going to say about long air travel and shipping, which is we clearly can do some short distance air travel with electricity, right? Batteries are getting better and better. They're not just coming down the cost curve, they're going up the energy density curve. And it is widely predicted that these curves that have been going for 20 to 30 years will continue. And so we will be getting better and better and better and cheaper and smaller and denser, energy denser batteries. So, yes, can you do short hop flights using electric planes? Yes, I think you can, and I think we probably will. Can you do shorter distance shipping? Well, the Chinese, I think it's the Yangtze, they are doing shipping along the river with a barge that, with a tanker ship that has those big rectangular giant shipping containers. They fill some of them with batteries. And then they simply switch out when they get to a new station on the river. While they're offloading some of the other containers, they offload the battery containers and they put on a new set of batteries. So they can go up and down the river. Again, this is a very new thing. So the hard things are going to be intercontinental air travel and intercontinental shipping. And that's each of those might be 2% of global emissions. And so I think typically what I would say and others would say is we don't have to solve all of our problems tomorrow, right? We can do 80 to 90% pretty straightforwardly with existing technologies or technologies that are in the process of being commercialized. There are some that are very hard, and please don't force us to do the hard stuff now, stuff that we should still be spending a lot of money on research and development. So I would say, yeah, we don't have to solve the intercontinental air travel. Is it possible that we could end up doing most of it with electricity? I think based on people I've talked to, I think the answer is yes, because I think that we may end up hybridizing, as already some people are. You can hybridize an intercontinental jet and use the electricity where that's the best, and then use the jet fuel that you might make in a greener way for what's rest. I mean, and we burn a fantastic amount of jet fuel just taxiing, right, and then taking off and landing. And if you could do takeoff and landing electrically, that would be. And I know companies that are working on that. There's also these very advanced batteries called structural batteries that are ways away from being commercial. But the possibility of designing a battery that would actually be built into the structure of the plane, right? So again, not anytime soon, but I just think that anyone who says, oh, that has to be solved with hydrogen, or it has to be solved with jet fuel made from hydrogen and captured CO2, I would say no, we don't know that's true. Let's do the straightforward stuff and let's spend a lot of money on R&D on these alternatives so that come the year 2040 or even 2035, we have a better idea what the winner is. But it would be a very big mistake to force companies to build steel plants that could only run on hydrogen, right? Because if it turns out you can't deliver green hydrogen cheaply and someone comes up with a better direct electricity process, you've now got a multi-billion-dollar stranded asset, right? And that's just not a good investment. It's not a good gamble at this point. And I do think, you know, it's one of the reasons I wrote Hype About Hydrogen. We don't want to get distracted by bright, shiny objects that aren't ready for prime time.
Your research at the Penn Center for Science, Sustainability, and the Media examines the viability of various climate solutions. What are your main concerns about the effectiveness and scalability of carbon offsets, and why do you consider them a potential threat to the international agreements on climate?
Let me wind up with this question. I've written a lot about this subject for a very long time, and I in June of 23 I published an extensive paper at the Penn Center for Science, Sustainability, and the Media, and I'm in the process of finishing up a major journal article on the subject. I think the most important thing for people to realize is that we now realize that the world needs to get as close as possible to zero emissions by mid-century as possible. And would it be nice to get to zero? Yes. Are we likely to get there by 2050? No, we're not likely, but we really need to get as close as possible, right? Offsets don't actually reduce global emissions. They are just one country paying someone else to reduce their emissions so I can keep polluting, right? That's what they are, right? So if your goal is to actually reduce global emissions, then the current offset market doesn't help solve your problem if the offsets were real. Now, we have a very extensive literature dating back 25 years that offsets it is very hard to design an offset program that isn't easy to game and that doesn't urge people to exaggerate how good their offsets are. And first of all, would the project have happened without the money anyway? That's the additionality problem. Is this project additional? And a great many of the projects that we have done over the last 20 years have clearly not been additional. Study after study after study. For a long time, people wanted to use renewable energy as an offset. But the problem is the good news was renewables became the cheapest thing, right? So the offsets needed to make them happen became so low price. In other words, they were the winner in the marketplace without the offset, right? So you could still buy offsets today from supporting renewable projects that would have happened anyway, right? So that's just money flushed down the toilet. And as it turns out, a great many projects are not additional. So that problem has never been solved. You then have this problem called leakage. That's the problem where I'm going to pay you not to cut down those trees. Well, okay, but somebody still wants trees for forestry products or land they want to put agriculture on. They'll just do it somewhere else, right? So if you're going to sell me 1 million tons, how do I know someone else isn't going to cut down the equivalent amount of trees somewhere else? And the studies show leakage rates are typically like 80%. In other words, yes, the people who want to cut down trees are going to find somewhere to cut down those trees. And that problem has never really been solved. You have the overcounting problem, which is just that it is very hard to estimate what would have happened otherwise, right? And this is the counterfactual. So I'm going to build some cook stoves that are going to stop, and the cook stoves are going to allow me not to deforest as much because they're much better, higher quality cook stoves. Well, how much? Well, that requires somebody to figure out the baseline of what would have happened otherwise, right? Well, the person who comes up with the baseline has an incentive to exaggerate how good that this change is revolutionary. Well, maybe things were already getting better, right? So these are very hard calculations to do. And then maybe the other very big problem is the permanence problem. And this is the point that really got emphasized by a couple of major papers that came out during COP29 in Azerbaijan in November, which basically said that if you're going to offset fossil fuel burning, if I'm going to burn fossil fuels, stuff that have been trapped in the ground for a long time, and I'm going to release it, and it's CO2, and it lasts in the atmosphere for hundreds of years, then the offset that I use has to be something that also lasts hundreds of years, right? I can't plant a tree, right? First of all, the tree is going to take 20 years to grow to maturity and store the CO2 because I'm not planting a tree, I'm planting a little seedling, right? And plus, the tree might get first of all, the seedling might get washed away, it might get eaten, it might get disease, might kill it. It might get bigger and burn down in a wildfire, right? It's not permanent. So it's these major scientists, the people who basically came up with the whole idea of net zero, they said you have to offset like for like. So if you want to say I can burn uh, 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 oil in my car and I'm going to offset it, you can't offset it with tree planting. You got to offset it with something that's pulling actual CO2 out of the air and permanently burying it for centuries. Well, that's expensive, right? That's not cheap, right? The cheap the average price of offsets is just a few dollars, right? The solution to the problem of climate change is not a few dollars a ton, right? You get what you pay for, and that's what the offset market. The great magical thinking of the offset market is that there are staggering amounts of tons in the developing world that we can pay them to reduce and we can keep doing what we've been doing all along, right? And it's just, I will say, it's ridiculous. It's also kind of colonialism, right? We're going to skim off their reduction so we can keep doing our regular pollution. And I want to be very clear, the scientific literature could not be clearer that offsets don't solve, we haven't solved the additionality problem, have not solved the leakage problem, we have not solved the overcounting problem, we haven't solved the permanence problem, and very low percentage of offsets, whenever someone goes and measures them in the real world, are actually verifiable, additional, and permanent. And if they were, they would be expensive and no one would buy them. And the stuff that people are willing to buy, a few dollars a ton, those aren't real. It's just a great disservice to the world to pretend that the solution to climate change doesn't, all these companies out there, reduce your own emissions to zero. Don't go around saying if you don't think you can, just say so, right? But this pretend world where you're net zero, but you're buying cheap stuff that isn't real somewhere else, that is greenwashing. And by the way, there have been a staggering amount of lawsuits in this country and Europe, and repeatedly losing in European courts. The FIFA, the soccer federation, tried to claim that the World Cup 2022 was carbon neutral based on buying renewable energy offsets from a company in Qatar that was set up to sell those offsets because the legitimate offset companies, principally Vera and Gold Standard, stopped having renewable energy offset projects in 2019 in most countries for this reason I said, right? But the point is, anyone can set up an offset company. Anyone can start a company, as the government of Qatar did, that would issue offsets and be a verifier of offsets. And that company said, we'll take all comers, right? So the point is, the voluntary market, you cannot enforce quality because it's voluntary, right? There's no regulations, there's no cop, there's no one calling balls and strikes, there's no referee, right? That is the inherent flaw and danger to the Paris Agreement, is that in a world where you have a regulated market for offsets and a unregulated market, the unregulated market is going to drive prices down because people are going to want to buy cheaper stuff. In the summertime, I'll be coming out with a major article that I think will really hopefully make this clear just how clear the science is on all of this.
Dr. Ram, thank you so much for your time
Sure.
and your wisdom and insights today. We're honored to have you on Clean Titans.
It was a great pleasure being here.
To our viewers, please join us next time for more insightful interviews in the clean energy transition. Please subscribe, share, comment, and ask questions, and we'll get you the answers. Please tell your friends about Clean Titans. Thank you.